Hello and welcome back to the Go-Stroid development series. Today we'll be reworking our entity spawner to enable an infinite level, some difficulty scaling, and then we'll be making some great changes to our health and damage numbers, which were actually suggested by Beck, one of our amazing community members. So thank you, Beck. Remember, if you want to have input onto the project or future projects, leave an idea in the comment or just come down to the Discord and chat with us. We're all super friendly, we don't bite. Yeah, it's the best way if you want to actually, have input on the project. Anyway, let's first handle the damage numbers and things, because that's going to be relatively simple. Now, what Beck suggested was using the Fibonacci sequence numbers because it just makes kind of balancing a lot easier. So that's kind of what we're going to do. Now, I will flash something on the screen to show you basic Fibonacci sequence numbers. It's this is where my brain needs to remember the Fibonacci sequence. It is 1, then 1, 2, 3, 5, and basically the way it works is you are adding the previous number to the current number, and that's your new number, and then you kind of keep incrementing like that. That's a very, very, very simple explanation for the Fibonacci sequence. I don't even know if it's fully correct, but that's kind of what we're doing. So with that in mind, let's go to our... Let's do the player's damage first. So in the file system, in the bottom left corner, we are going to write player, and then we'll close these PNGs, and we'll go to the player projectiles, player primary laser 1. Now it is currently 2, and that's fine, but we actually want to use 3, because 3 will actually scale a little bit better with the damage number, or the health numbers or values I want to go with for our meteors or asteroids. So let's go and change those now. So let's go back to the file system and type in asteroid. We'll open the large asteroid TSCN and the small asteroid TSCN. We're going to change the large asteroid first. So let's go and do the large asteroid's health handler. I'm going to be changing the health for the large asteroid to 13. So with us doing 3 damage per shot and the asteroid having 13 health, that is 5 shots for us to destroy the asteroid of large variety. That's great. But that means if we get a +1 damage upgrade, so if our damage goes from 3 to, say, 4, it now goes down to 4 shots per asteroid. And it's just that little minute change that actually ends up balancing things very, very well. And it also gives us a little bit more wiggle room. So that's the health done. Now, the next thing I want to do real quick is actually kind of adjust some of the sizing. The sizing and stuff on the large asteroid is okay. I want to change where these hitboxes are located. So the first one, the hurtbox handler, is in a good place. The hitbox handler, not so much. So let's pull that down to the center and let's increase the size of that a little bit. And then hit Control S and save. That's now more centered and looks a little bit better. Now let's go do the small asteroid. Now, if you remember correctly, in the previous video, or when we talked about making the small asteroid at least, I talked about how inheritance kind of works and how making a change in the large asteroid will now change it in the small asteroid. Now, of course, that's not going to change too much in the small asteroid because we have our collision shapes here set to unique, so we can modify these as much as we want. Now, that also means the health can be changed, which we are going to change that to 8. So let's go and change that to 8. Hit Control S and save. Go back, triple check, make sure this hasn't changed. It has not. And now the sizes. I wanted to change the size of the small asteroid because right now I feel like it's 1, a little bit too fast, and 2, just a little bit too big. So let's change the move speed down to, let's just say 5. And now let's go and change the Sprite 2D's size. So the scale is going to go from 1 to 0.75. It's going to make it smaller. We'll hit Control S or Command S and save. Go to our collision shapes and we'll start kind of moving these around a little bit. We'll center them. The hurtbox looks good. The hitbox looks kind of okay. I want the hitbox to be a little bit bigger and the hurtbox to be a little bit smaller. There we go. Hit Control S and Command S and save. And now that is the damage kind of balanced here. Let's go press play. Find out. So it should take 5 shots to break the large asteroids. 1, 2, 3, 4, 5, and they broke. 1, 2, 3 to break the small asteroids. Perfect. So we now have our damage numbers feeling just a little bit smoother. Now, one more thing I want to do is if we spam click, we can fire as fast as we click. And now, in some cases, that's, a-okay. But for us, I actually don't want that. So what I'm going to do is go to the main scene, go to the player ship, open the scene. Now, the weapons handler is the thing that is in charge of handling, well, the weapons, right? It's handling how often we can fire and how we can fire. So what we're going to do is we're going to open the weapons handler scene here, so the player weapon handler, and we are going to left click on the root, use Control A to add, and we will add a timer node. Now, this is just going to be the fire rate timer, so fire rate, that's what I'm going to name it to, like so, so fire rate timer. Now in the script, let me adjust these window sizes a little bit, make it a little bit more easy to see. Here we go. I'll close the output. So in the player weapon handler script, we're going to control left click drag and then hold down control, as we drop to make the onReady variable for it. Actually, do we even need an onReady variable? We don't need an onReady variable. So yeah, we'll create an onReady variable and we'll do this a little bit differently than what I originally planned to do. So we have our timer, right? The other thing we're going to want to do is create an exported variable. So let's go and do that. Export var, we'll call it fire underscore rate of type float and set that equal to, let's go to 0.5. So every 0.5 seconds, we should be able to shoot one projectile. Now, as of right now, as I said, we can click as fast as we want, we can fire as fast as we want. So what we're going to do here is we are going to create a Boolean. So we'll go var, we'll go can underscore fire of type bool, so that equal to true. It needs to be set to true first. And then if input is action fired under fire of primary weapon, and, so you can write the word and, or you can use ampersands, which are these little things here. So I'm just going to use the now we'll write and, because it makes it more readable. So and can fire, so and can fire equals true, do this. And then what we're going to do is at the very bottom here, we're going to create a new line inside of the if statement, and we're going to set can fire equal to false. So what that's going to do is stop us from being able to fire. Now, then the final thing we want to do, of course, is actually grab our fire rate timer. So we can go fire rate timer dot start, and then we can pass through the fire rate. So now the timer is going to start. We're going to make sure it's on one shot here. So click on the timer, go to the inspector, make sure it's one shot. That's going to fire the timer. We can now go to node. If after we click on the timer, we go to node, signals, grab the timeout function, connect to that, add a new line there, make it look nice and neat. You'll notice, by the way, there's a little thing. I like to have 2 lines between each function that I create usually. It just makes it look a little bit cleaner and easier to read. Yes, on the fire rate timer's timeout, all we got to do is write can fire, and so that equal to true. Hit Control S or Command S and save. Now we can hit play, and we can now fire 0.5 seconds. I'm clicking as fast as I can, and this is as fast as we can fire. Now that feels just a little bit too slow, so let's go and adjust the fire rate here. Go adjust that down to 0.25, so double that fire rate. That feels a little bit better, and it means I have to think a bit more about how I fire and where I fire. So that is all of the damage numbers and a fire rate system implemented. Now let's actually move into, I'm going to close out a bunch of these scripts real quick. Close out all of these scenes. There we go. Change the output, go down to the 2D script. Let's go and start modifying our entity spawner, right? So let's open the scene on the entity spawner from the main, and open the script as well. Now, one thing I've noticed is we have here in the ready function spawn asteroid. Now that's fine, we can actually remove spawn asteroid and just write pass in the ready function for now, and then go to our asteroid spawn timer here, and then let it, just go on auto start. We'll set it for 1 second, like so, there we go. Control S and save, Command S and save, and now it will still spawn the asteroids. As you can see, it's still spawning the asteroids. It's spawning them every 1 second up to the limit that we've set. But yes, it being in the ready function wasn't entirely necessary, so we don't need to have it in the ready function. Now, what I wanted to change, or what I wanted to kind of rework or add in the entity spawn manager here, was I wanted to kind of start adding things like difficulty scaling, which means we actually need to have some way of calculating the difficulty. But when we do that, there is this issue that we run into of, if we kind of set it up in a certain way, it will just kind of start spawning large asteroids every so often, right? Because we're not keeping track of small asteroids, which means if it consistently spawns large asteroids and we keep breaking them, there will be an infinite number of small asteroids on the screen, and that becomes a bit insane. So that's what we're going to go and fix first. We'll set up the infinite play, but we'll also make it so it's a bit safe. So to do this, we're going to create a new line under the maximum spawnable large asteroid variable. We'll make an export var, and we'll go maximum underscore spawnable underscore small underscore asteroids of type in, and we'll set that equal to, let's set that equal to 2 as well. So that's going to be the same number for both right now. And then we will do another new line, export var, and we will make the amount of asteroids we can spawn. So small underscore asteroids underscore spawn underscore amount. And we're going to set that equal, an integer equal to 3. So we can spawn 3 asteroids, but there needs to be a maximum amount on the screen of 2. This is basically just our checking condition. If there is 2 or more small asteroids, then we don't want to spawn any more large asteroids. So that's actually the check we need to do. But how are we going to keep track of those asteroids? Well, I have 2 ways that I've been keeping track of the large asteroids, right? I've been adding them to a group, and then I've been adding them to an array. Now, funny enough, I said when I set this up that I don't know which one I plan on sticking with and using. I plan on sticking with the group. Why? Because the group is pretty much just an array that we can use, which is great. So I'm going to remove var asteroid count array and remove that array. Now, the second I do that, this is going to pop up with some warnings for line 42 and line 52. So we can remove the array appending inside of spawn asteroid here. So we can remove that. And then coming down to here, we can see that in is asteroid spawnable, we're having another issue, right? An array issue. So to fix this, what we can do is we can use get underscore tree dot get underscore nodes in group. Then we can pass through the asteroid group, and then we can use dot size. So that's pretty much what we have been doing, right? We've been using it as an array because this is an array of type node. And that will work the exact same way, but now it will just start spawning asteroids a little bit better because we can actually keep track of how large this array is, right? So if I go and hit play and I let it spawn 2 asteroids, you see 2 asteroids, and now I go and break 1 asteroid. Now it spawns another large asteroid. But that once again leads us into that issue where if I break another asteroid, and without dying, there we go, it'll spawn another asteroid, and we have all of these small asteroids on screen. So this, for one, is quite long, right? Let's fix this first. This is a very, very long kind of statement to be using here, and it starts to go off screen a little bit. So I'm going to scroll up a little bit above is asteroid spawnable. And I'm going to create a new function. This is going to be called get underscore large underscore asteroid underscore count. It won't take any parameters, but it will return a value of int. So it's an integer return. And then we're going to write return. And then in our if statement that we have down here with the get tree, get nodes in group, we can just hit Control X or Command X and cut, and then paste that into the return statement. And now get large asteroids will do the same thing, but it will be smaller and easier to read. So we can now just place them, or call that inside of the if statement, like so. And now it's doing the same thing, just a little bit more legible. So that's the large asteroids. So let's scroll to the top again, and let's start thinking about how we can do small asteroids. Well, let's do the same thing. Let's go const small asteroid group of type string, and then we'll set that equal to small asteroid, like so. So why am I doing this? Well, if we scroll back down to how we are spawning our normal asteroids, we are just adding it to a group like so, right? We are just looping through, well, we're not even looping through, we're just going, okay, on the asteroid spawn, add it to group, which means if we scroll back down to our small asteroid spawn, we're going for new asteroid in amount of spawnable asteroids, do a thing. Now, if I remember correctly, what we've just done here is we've just changed. So with the change that we made in here to adding the spawn asteroid small amount, we can actually remove this variable for amount of spawnable small asteroids. Now that's going to throw that error back down into the small asteroid spawning function. So for new asteroid in, instead of amount of spawnable asteroids, we want to write, if we just write small, we can go small asteroids spawn amount. So it's a little rename, but it kind of keeps our brains a little bit more active on what's actually happening. So we now know we are spawning 3 asteroids at a time. Cool. Next thing that we want to do is actually make sure we're running the check, right? So if we go to the isAsteroid spawnable function here, we are checking if we could spawn large asteroids, only dependent on how many large asteroids there are. So let's do the same thing, but with small asteroids. But to do that, let's create another function similar to the get large asteroid count. Let's go func get underscore large underscore asteroid underscore count. Return type integer again, so same as before. And then we can pretty much just copy this return line and then paste that in and change asteroid group to small asteroid group like so. Hit Control S or Command S and save. I did get large, I will get small asteroid count. There we go. My brain is on autopilot at the moment. So we have a return function for the get small asteroid as well. Let's scroll down back into our isAsteroid spawnable, and now let's do the same check. So what we're going to want to do here is, instead of doing and, because if we do and, both conditions need to be true, we actually want or. So let's do or. Now I'm going to use a backslash to create a new line, so it's a little bit easier for us to read, so it's all on one page. And then I'm going to basically do the same check. I'm going to go get small asteroid count is greater than or equal to a certain amount, right? So what do I want to do? Let's just put 5 in for now. Oh wait, no, sorry. Let's do maximum spawnable small asteroids. There we go. Now hit Control S and save. Do one more new line there to make it a little bit easier to read. Yeah, we'll leave it like this. This looks a bit easier to read than if it's all on one line, which is great. So the new question becomes, well, we're not actually putting any small asteroids into the group yet, are we? So let's actually go and handle that. Let's scroll down to spawn small asteroid. And then in our for loop here, for spawning new asteroids, let's create a new line at the bottom. And then let's go new small asteroid dot add to group, and we'll add it to the small asteroid group. Now if I hit Control S and save, then I hit play, what we should get here after we break a rock, so we have a bunch of small asteroids all flying around. It's not creating a new asteroid yet. Let's go and blow up some of these smaller asteroids. I'm starting to realize I suck at my own game. That's great. Wow, I died. I would, you know, let's just do this real quick. Go to the player damage, and we will crank the player damage up to, let's just do 20 for now. It's just like a, hey, just get rid of the boulders as a test. So bang, that breaks 1, that breaks 2, that breaks 3, and it immediately spawned a new asteroid. Now I can break both of these and it didn't spawn any new large asteroids. So let's lower the amount of small asteroids, and eventually, there it is, it spawned a large asteroid. So now we have an infinite replayability thing, right? And that's really, really cool. Now, I want to add the foundations of a damage scaling, well, not damage scaling, a difficulty scaling to this. So how do we go about kind of adding that? Well, we're going to need a bunch of new variables, right? So let's go and create those. Now, the entity spawner will be in charge of this for now. We may change this in the future. And in fact, there is a lot of math that goes behind this that we also may end up changing. So let's create a new exported... Actually, no, let's create a new variable first. This variable will be for the current underscore difficulty. I can spell difficulty. There we go. Difficulty underscore level. So we want to, keep track of what our current difficulty level is. So it's an int. So that equal to 1 to start. So we now have our difficulty level. Our current difficulty level is 1. So we're going to need a way of incrementing that. We'll create a new function for that, but first, one thing that I've noticed with this is it's always a good idea to make sure you have a kind of progress limit starter, or, basically how long a level should quote unquote last for. Now, we're not doing this as timers, we are doing this as a score-based thing. So let's go above that variable we created and create a new export var. And we'll set this, or we'll call this the difficulty. I can spell difficulty today. There we go. There we go. Difficulty level underscore limit. So this is basically going to be a maximum limit on how high the score has to get to increase the difficulty level. So I'm just going to set this to a number that I kind of felt comfortable with when I was testing, which is 475. So technically, that's a bit of a really odd number, right? Because we're only incrementing the points by 150. So why 475? Well, that's because I kind of just like weird numbers with this. It doesn't need to be 475. You could just flat out do a 500. But I figured out that 475 makes the start of the game feel kind of smooth. And then as you progress, it kind of keeps the scaling at a decent speed rather than it going a bit crazy. So that's the difficulty level limit. Now, the last thing I want to have a variable for is a multiplier for that, right? So I want to be able to go and add an adjustable multiplier to the level limit. So let's go and create an export var for the difficulty. I'm having difficulties spelling difficulty. Level underscore multiplier of type float, and we'll set that equal to 1.2 for now. So we have the limit, the multiplier, and the current difficulty level. Let's hit Control S or Command S and save. Now let's go and think about how we will plan on getting the score. Well, if we go and check the score manager, so in a file system, we go down to the score manager.gd, we have a signal here in increase score. So every time something needs to increase the score, so every time an asteroid gets exploded or something, the score increases, right? This signal is called and then it's used into here. And then this is firing a new signal for get score, and it's passing through the current score. So that means we have a globalized signal that we could use that we're setting for UI stuff that we can actually just tap into with the entity spawn manager just to get the scoring. So let's go and do that. Let's go entity spawn manager, go under the ready function into the signal bus, and we'll use dot get underscore score dot connect, and we will connect this to the handle underscore difficulty underscore level function, which means we need to create that function. So let's copy that, scroll all the way down to the bottom where we create our new signal things, do a couple of new lines, write func, and then paste in the handle difficulty level. Remember that this is going to need a parameter for the current score, because that's what the signal takes. So current underscore score of type int with a return type of void. Now we can start messing with our current difficulty level, right? So what I want to do real quick is I want to do a print statement. I'm going to go print. I want to print, the first word will be score with a colon, and then I'm going to write plus, and we will go and do the string, so string conversion for the current score. And then I will write plus. I'm going to use a pipe or a straight line, which is this. One more plus. And then I will do the, sorry if this is a little bit complicated, it's a lot of string concatenation in a very, very kind of dumb way, but very quick thing just to make sure we keep track of our score and current difficulty level. So I'm going to write level and then plus the str, so string conversion for the current difficulty level. So I'm going to hit Control S and save. I'm going to write or click run. Now, every time we blow up an asteroid, because of how the signal is connected, we should get a score and the current level, right? So we're getting our current updated score and the current level, which means we can now start modifying it. So I'll keep that there for now. How do we want to do this? Well, the math behind this is going to be kind of simple. The first thing we want to do is check if the current score, so current score is greater than or equal to something, right? But what's the math behind the kind of how we want to do this? Well, I want to take the current difficulty level, so that'll be at the very start 1. I want to times that. Now I'm going to do this in parentheses to make this a little bit easier afterwards, by the difficulty level, so the difficulty level limit times the difficulty level multiplier. So what that's basically going to do is, it's going to times this by, times these two together, and then it's going to times it by, or this by the result of that, and it will kind of just pop out a number for us, which is really nice. You'll see this kind of a little bit better in action, and I did a lot of testing around this, and this math isn't entirely my strong suit, I'll be completely honest with you, but this kind of is what worked. So basically, if the current score is greater than or equal to the value of this equation here, then what do we want to do? Well, we want to get the current difficulty level and then just go plus equals 1. So this is how we're going to increment our difficulty level. So I'm going to hit Control S and save. And the other thing that I might do here is I'm going to copy this equation. I'm then going to print out a new thing. I'm going to write EQ so we know it's the equation, and then go plus and that. And then I will string convert the result as well. There we go. Oh, I don't know why that's having an issue. It's because of a parentheses that's missing. There we go. Right, so let's hit Control S or Command S and save. We'll hit play, and we will just kind of check and see how this is turning out for us. So the equation is returning a 570, so that's the current score we have to get to before it seems to increment, right? So let's go and get this to 570 real quick. 500, 600, and there we go. So the new equation is 1140. So this is kind of our rough leveling system, right? We were at difficulty level 2. Get rid of some of these rocks that keep trying to murder me. We are at difficulty level 2, and we can kind of play infinitely and increase the difficulty level, which is really, really cool. And that is kind of as far as I want to go with this for now, because some of the fun things you can do with this, so we can do an if statement right after this current one. We can go if the current difficulty level modulo 2 is equal to 0. So what this is saying is, if the current difficulty level divided by 2 has a remainder of 0, we can do something. So in this case, let's just print the words UFO, because we're going to want to spawn UFOs at some point, right? That means when we get to things that can be divided by 2, so like 2, 4, 6, yeah, and it has a remainder of, there you go, like this, UFO, because we just got to tier 2, so we'll keep saying UFO. So it has a remainder of 0, do a thing. So this is another thing that we can do with this kind of scaling system. And in the next video, we'll be kind of implementing more and more things. We'll be going over UFOs and adding those. Yeah, and a lot of this math will change. This type of math isn't my strong suit, and I'm still doing a lot of studying around it myself. But for now, we have a incrementing difficulty system that we don't need to do 20,000 if statements for. Anyway, thank you for watching. That's all I have for today. I hope you've had a great day and a great game dev journey, and I will see you in the next episode.